I'm Michael Leif, and this is Project 1. For modeling my game state, I created a game state class that uses a two-dimensional integer array to represent each game state. I have a bunch of get and set methods within this class, and I think the most important part of this class is to generate the successors. And to do so, I have a move up, move down, move right, and move left method. And each of these methods checks to see if it can make that move by these different conditionals, and if it can, instantiates a new game state with the new board with the swap that has been made. For all the bookkeeping with each game state, I created a search node class, and this class has the parent node, the current state, the children, and the different costs and moves associated with each game state. And I have a bunch of get and set methods, and this is probably the most important part, again, is generating a bunch of different game states. And this kind of wraps around the other successor function in the game state. Okay, the first algorithm I implemented was the breadth first search, and for this algorithm I use a queue and a hash set. The queue is to keep track of the next node I'm going to visit, and the visited set is to make sure I don't visit the same node twice and get caught in an infinite loop. And for this, I just have a while loop that says if the queue is not empty and I have not found the goal state, then it checks to see if the next node is the goal state, and if not, it generates all the successor children it can from the current search node, and then it goes through this, and it says if it's not visited, then it adds it to the visited set. Also, it enqueues a new search node onto the queue, which has all the necessary information it needs, and it keeps on doing this until the queue is empty, or it has found, or my algorithm has found the goal state. This is the depth first search algorithm, and it is almost identical to the breadth first search, but instead of using a queue, I use a stack. So instead of having a LIFO structure, it has a FIFO structure, and basically it says when the stack is not, while the stack is not empty and not found, it goes through this while loop and does the same thing as the breadth first search, but instead of dequeuing from ahead of the queue, it pops from a stack. Okay, this is the uniform cost algorithm, and to do this I made a compare method which compares the cost of a search node, and I instantiated a priority queue which uses this comparator method. So when I am dequeuing from the priority queue, it removes the min cost value, and the while loop's pretty much the same as the other algorithms. It's when the priority queue is not empty and not found, it checks to see if the search node is equal to the game state, and if not, it creates successors. Okay, this is breadth first search, and this algorithm goes through a while loop, and while the priority queue is not empty, it creates successors. But what's different about this one is when it pops from the priority queue, it pops the min g of n value, and the g of n value is the cost. So it's just removing the minimum cost. So it's using a greedy method to find the shortest cost, find the path of the shortest cost. Okay, this is my A star, which calculates f of n, which is h1 of n plus g of n. h1 of n is the sum of misplaced tiles within each game state. So every time it goes through the loop, it will create successors, and for each successor, it creates a new search node, which calculates the cost plus the number of misplaced tiles, and then when it dequeues from the priority queue, it will remove the min f of n, and it keeps on doing this until the goal state is found. Okay, this is my A star that uses h of 2, and it's the same thing as h1, but instead of calculating the sum of the misplaced tiles, it calculates the sum of the Manhattan distance. So each iteration it pops off, or not, it dequeues the min f of n, which is g of n plus h2 of n, and then it creates successors. And this is my main method, which does all the testing. So I have the ET, medium, and hard board, and the goal state. And for each search algorithm, it generates a file of all the needed information, which will be in my write-up. And I'm just going to run it to prove it works. And you'll see a bunch of text files be generated. Open them up. And that's all the information my main class generates.